In this video, you're going to be learning about rotations. Within this video, there are 2 YouTube videos that you will watch that will also help you out.
So let's kick off this lesson on rotations in the coordinate plane by watching these headphones spin around on a record. In geometry, we call a rotation a change in orientation. Note that a rotation is not a change in size, and that rotation should not be confused with reflections. Now we are going to reference 2 directions for rotations. Clockwise rotations move the same way that the clock does, and counterclockwise rotations just move in the opposite direction that the hand of a clock would normally move. Now, in addition to the direction of a rotation, either clockwise or counterclockwise, we are also going to reference rotations in terms of degrees. Just like this circular record, we're moving in a circular rotation, so our degrees are going to be between 0 and 360. Now, a positive degree of rotation is a counterclockwise movement. So we start with a figure, and making 1/4 turn is equivalent to a 90-degree rotation. A second quarter turn is adding another 90 to that, and 90 plus 90 equals 180, so this would be a 180-degree rotation. A third quarter turn would be adding another 90, this would be a 270-degree rotation. And a final quarter turn brings the figure back to where it started and completes the full 360 degrees. If we rotate in the opposite direction, this time clockwise, we will see that our rotations will be negative values. So a negative 90-degree rotation is 1/4 turn in a clockwise direction. A second quarter turn clockwise would be negative 180, which we notice puts it in the same location as positive 180. So a 180-degree rotation does not matter whether you move clockwise or counterclockwise, you'll end up in the same spot. Another quarter turn clockwise would be negative 270 degrees, and a final quarter turn would complete the 360-degree rotation and bring the figure back to where it started from. Now we will say that rotating a figure is a circular movement around a fixed point, and we use the capital R notation to denote rotations. Remember that when the degrees of notation is a positive number, the rotation is moved in a counterclockwise direction. When the degrees of rotation is a negative number, we move in a clockwise direction. For our first example, we are going to rotate a point. In this case, point C is going to be rotated positive 90 degrees. Since the degrees is a positive number, we will be rotating counterclockwise. We can start by writing down the coordinates of point C at 3, 6. Since point C lies in the first quadrant, we are going to imagine taking that entire quadrant and rotating it 1/4 turn. This allows us to find the location of the image C' with coordinates negative 6, positive 3. Now we can see what if, instead of a 90-degree rotation, it was a positive 180-degree rotation. So in this case, we would need 2 quarter turns of that first quadrant. So the first rotation is the 90 degrees. Rotate another quarter turn completes the 180, giving us the coordinates of the new image C' at negative 3, negative 6. Now if the degrees of rotation was 270, we would still complete the same process, but now we would need 3 quarter turns. So again, start with C in the first quadrant. 1/4 turn is 90 degrees, a second quarter turn is 180 degrees, and a third quarter turn counterclockwise is 270 degrees, giving us the coordinates of the new image C' at positive 6, negative 3. Now before we move on, let's just take a moment to visualize what we just did here when we rotated this point around the origin. In our last example, we applied a very visual approach to rotating a point around the origin. However, there are some rotation rules that we can also apply. When rotating counterclockwise for any point P with coordinates x, y, there are a set of rules for each type of rotation to find the coordinates of the image. Notice that those negative signs just mean to negate or do the opposite. So positive values would become negative and negative values would become positive. If we apply the point 36 from the last example, using these rules we see that for a 90-degree rotation, we would start with the y coordinate negated, so 6 would become negative 6. That's the new x coordinate. And then the y coordinate is the old x coordinate, which stays the same at positive 3. And we can repeat this process for the rotation of 180 and for the rotation of 270. Now, these points should look very familiar as they correspond directly with the points that we found in the last example using the visual method. If you don't think that's pretty cool, then I don't know what to say. Okay, moving on to our next example. Again, we're going to be rotating a point, in this case, a negative degree of rotation. Negative 90 degrees means we're moving in a clockwise rotation. We can see that D lies in the fourth quadrant with coordinates at 5, negative 8. Again, we're going to take a visual approach here. Imagine taking that fourth quadrant with point D contained inside of it and rotating the entire quadrant, in this case, in a clockwise direction. Now we can find the coordinates of the image D prime with coordinates negative 8, negative 5. Now let's go ahead and take that same original point D and perform a negative 180 degree rotation. Again, we take that fourth quadrant, 1/4 turn clockwise is negative 90, a second quarter turn would be negative 180. Now again, we can find the coordinates of the image D prime at negative 5, positive 8. Now we'll take a look at what would happen if instead of a negative 180 rotation, it was a negative 270. Again, start with D in that fourth quadrant. 1/4 turn is the negative 90. A second quarter turn is negative 180. We need one more third quarter turn to get to negative 270 with the image D prime at positive 8, positive 5. Now that we have completed all of the degrees of rotation in a clockwise direction, let's go ahead and visualize what we did on that last example. Now, just as we had rotation rules for counterclockwise rotations, we have another set of rules for clockwise rotations. So for any point P with coordinates x, y, we have a set of rules for negative 90, negative 180, and negative 270. And again, those negative signs just mean to negate or to switch the sign. So if we use the point from the last example, 5, negative 8, by applying the negative 90 degree rule, we start with the y coordinate, negative 8, and then the second value is the negated x coordinate, so negative 5. Now you can go ahead and apply these rules for negative 180 as well as for negative 270 to get the coordinates of those images. Now again, these points should look familiar because they correspond with the points that we found in the last example using the visual method. So basically it's up to you to decide which method you want to use. They each work effectively, but if you're going to use the rules, you're going to have to memorize them. Okay, so now we're going to step it up and take a crack at rotating a line segment. In this case, we want to construct E prime F prime after a clockwise rotation of 90 degrees. So that would be a negative 90 degree rotation. Now we can start by writing down the coordinates of the endpoints E and F. And we want to find the coordinates of the image of E prime and F prime. So again, we just want to take the entire quadrant that EF is in and rotate it 1/4 turn clockwise. This allows us to find the location of the new line segment E prime F prime. Once we construct the segment, we can see that E prime is at negative 8, 9, and that F prime is at negative 6, 4. So basically all that we did was take that line segment EF and rotate it 1/4 turn clockwise about the origin. And for our final example, we're going to take a shot at rotating a figure, in this case a positive 180 degrees. So we start by writing down the coordinates of the vertices of triangle LMK, and we're looking to find the coordinates of the image of point L prime, M prime, and K prime. Now, since it's a positive 180 degrees, we're going to take this figure and rotate it 2 quarter turns in a counterclockwise direction to get it to its final location. However, if we actually made a mistake here and went the wrong way going clockwise, we see that we would end up in the same spot. So if you remember from earlier, for 180, it doesn't matter whether you go clockwise or counterclockwise, you'll still end up in the same position. Now, using our visual approach, we construct 3 reference lines, and we're going to go ahead and rotate that entire quadrant 2 quarter turns in a counterclockwise direction. Now we can construct the image of the new figure, identify L prime, K prime, and N prime, L prime with coordinates at -2, -6, N prime at -8, -8, and K prime at -7, -4. And now for our final words on rotations. A rotation is a circular turn around a fixed point. We also say that a rotation is a change in a figure's orientation. Remember that positive rotations move in a counterclockwise direction, and that negative rotations move in a clockwise direction. Nailed it! Please follow.
Okay, hopefully you found that helpful. It's a lot better than I could have done, trust me. So now we're going to go ahead and I'll just show you some of the rest of the notes, and then there's another little video I'm going to insert for you to also watch. Okay, so let's get the notes ready for you. And let me go through this a little bit. You already got the definition. Rotations are turns, so I'm not going to write anything more on that. The images below show the clockwise rotation, which is a negative rotation of a figure with a center of rotation at point A. And you can see that I've written the 90-degree rotation is a quarter turn, 180 degrees is a half turn, and 270 is 3/4. Okay, now we have an ice cream cone. After a 90-degree clockwise rotation, where will it end up? I showed you the quarter turn and where it would end up. Same thing here, 270-degree clockwise rotation would take us 3/4 of the way around, okay? So you can kind of see that is right here. Okay, if we had to do a 180-degree counterclockwise about point C, remember, when you do counterclockwise, or with 180 degrees, it doesn't matter if it's clockwise or counterclockwise. Let me just kind of draw you a purple ice cream cone. If you were to do a 180-degree rotation, it would simply basically be upside down. Okay? Okay, let's go ahead and keep going now. Whoops, having a trouble moving my board. Let's go ahead and try to fix that. Okay, here we go. Let me go to the next page. Okay, so now I want you to try a few on your own. These you're going to need to show in your notes, okay? So please show me that you're paying close attention by realizing that you need to show these, okay? Draw each figure after the rotation described. A 90-degree clockwise rotation about point R, and then for the second one, 180-degree clockwise rotation about point S, okay? Those are the ones, one is an L and one is a star. All right, now, this is when things get tricky, okay? When we get to this example 2, you're taking a figure, this is a quadrilateral, and you're gonna be rotating it around a certain point. This time you're going to be rotating around point X, okay? Not the origin. When you do this around a point that's not the origin, it is very tricky. So I have another video that I want you to watch so that you can see how to do that. Okay, let's get her started. Hold on, for some reason there's no sound. Okay.
The one that's rotating about the origin. All right, I am going to show you how to rotate an object about a point other than the origin. I will encourage you to watch my rotations video, the one that's rotating about the origin first, prior to watching this, if you're still kind of confused about rotations, because in that video I discuss more specifically about rotating 90 degrees, 270, 180. This video I'm going to focus mainly on the point that you're rotating, and I'm not going to give you a whole lot of different examples with the different angle measures, okay? All right, so for this one, just to kind of zoom in for you. All right, so we have this triangle ABC here. We're going to rotate about this point right here, which is the point 2, -2. What you have to realize here is that when we're rotating about the origin here, that's different than rotating about this point. And you're almost going to kind of assume that this is the origin. And notice that the object here is different from this point than it is from the origin. So because of that, we have these pretend points that we're going to make, okay? So what we're going to do is I wrote each of the points here. So point A is at 2, 0, B is at 2, 3, and C is at 4, 0. And we're going to make pretend points. And this is not a mathematical term when I say pretend points. This is my term for these points. But the way we come up with our pretend points and making up, again, for this shift and what we're rotating around, is that we subtract this point, our point of rotation, from each of our coordinates. So I am going to subtract 2, -2 from each of these points. Okay? Now, you have to remember your integer rules here. Okay? So A, and I'm putting a little star here. Again, this is not a mathematical term. This is just my way of kind of helping you follow along with me as I'm saying this. This is going to be my pretend A, or what I'm moving it to. So 2 - 2 is 0. 0 minus -2 is +2. My new pretend B, 2 - 2 is 0. 3 minus -2 is 5. And then my pretend C, 4 - 2 is 2, and 0 minus -2 is +2. Okay, so these are the points right here, our pretend points, that we're going to apply the transformation to, or the rotation specifically. Okay, and we're going to go 90 degrees counterclockwise. So just eyeballing the object, I know that it's going this way, 1/4 of a turn. Okay, and the rule with 90-degree counterclockwise rotation is that you swap your X and Y and change the sign of your X. So I'm going to swap my X and Y, change the sign of my X, swap my X and Y, change the sign of my X, swap my X and Y, change the sign of my X. Okay? Now, because we subtracted this point from here to get these pretend points, we now have to add it back in to get the new value. Okay, so we're going to add it back in because it kind of cancels out. That just is a way of canceling it out. So we're going to add that point back in. Okay, so -2 plus 2 is 0. 0 plus -2 is -2. So A prime, that's this initial point, rotated about this point 90 degrees counterclockwise, gives us this ending point of 0, -2. Okay, B prime, -5 plus 2 is -3. 0 plus -2 is -2. And then C prime, -2 plus 2 is 0. 2 plus -2 is 0. All right, so I'm going to go back and I'm going to plot these points. So A prime is at 0, -2. B prime is at -3, -2. And then C prime is at 0, 0. And so again, this is shifted this way, and it's shifted 1/4 of a turn. So if you look at it, this is like kind of like our pretend center now. You can see that you're going 1/4 of a turn that way to the left, and that's the counterclockwise. Okay, so let me do another example with you. Let's say we have this rectangle ABCD, and we're going to rotate it 180 degrees. And it doesn't matter when you're going 180 degrees if you go clockwise or counterclockwise. And our center of rotation is going to be -1, 2. So when I rotate this, -1, 2, again, we're going to have to make up each of these points, make our pretend points to kind of make up for this different center of rotation since we're not using the origin. So I'm going to subtract -1, 2 from each of these points. Okay, and when I do that, I get that again, remember this is my pretend A. This isn't a mathematical term. This is just my way of kind of helping you stay with me. Okay, so -6 minus -1 is like -6 plus 1, which is -5. 1 minus 2 is -1. My new B that I'm going to work with here is -6 minus -1 is -6 plus 1, which is -5. And 3 minus 2 is 1. My pretend C, -3 minus -1 is -3 plus 1, which is -2. And then 3 minus 2 is 1. And then my pretend D, -3 minus -1 is -3 plus 1, which is -2, and then 1 minus 2 is -1. So we're applying a 180-degree rotation, and the rule for a 180-degree rotation is you just change the signs. So if it's negative, it becomes positive. If it's positive, it becomes negative. So this is going to be 5, 1. This is 5, -1. The C is going to be 2, -1, and D is going to be 2, 1. Okay, but again, we have to compensate because we subtracted this rotation point, so now we're going to have to add that point back in. Okay, so we're going to have to add in -1, 2. All right, so when I do that, my A prime is going to be 6 plus -1, which is 4, 1 plus 2, which is 3. So A prime is at 4, 3. B prime, 5 plus -1 is 4. -1 plus 2 is 1. C prime, 2 plus -1 is 1. -1 plus 2 is 1. And then D prime, 2 plus -1 is 1. 1 plus 2 is 3. So let me graph these. So A is at 4, 3. Actually, let me change colors. Okay, A is at 4, 3. B prime is at 4, 1. Oops, didn't put my prime there. C prime is at 1, 1. Actually, yeah, okay. And then D prime is at 1, 3. So, oh wait, did I mess up? Yes, I did. That's 1, 4. No, that's not a straight line. Oops. All right, you get the idea. All right, so again, you can see that everything is rotated about this a half of a turn. So here's our rotation. Everything's rotated that way. Okay, 180 degrees. All right.
Okay, hopefully that helps explain how to do this around a point. Again, this is the most confusing part, so it's the hardest part. All right, I'm going to go ahead and show you the rest of the note sheet for yourself. Okay, so let me get you to where we need to be, and let's clear. So, for example, what I'm going to do here actually is show you that you've got some rules listed. You've got the rotation rules here. These are written very confusing, I feel like. So I've got some better screenshots at the end that you can use. Okay? And you already saw an example. So we're going to go ahead and just go on to this one here. This is the end of part 1 due to a TouchCast time limit, so you'll see a short part 2 also.